In this video, we are going to talk about projectile motion. So I've got a number of questions with me here, which I want us to solve together. So one thing I'm going to advise you is you can just pause the video, solve the question, then see how I'm going to solve it. So there we go. We have got question 1. Now we have got question 1a. So question 1a is saying a stone is thrown horizontally with a velocity of 12 meters per second from the top of a vertical cliff. Calculate part 1, how long the stone take to reach the ground 40 meters below. Part 2, how far the stone land from the base of the cliff. Now, when we're talking about projectile motion, I want you guys to understand one thing. When we're talking about projectile motion, we're talking about the motion in 2 dimensions. The motion, an object is moving in both x and y direction. Okay, so you throw a ball, it goes like that. So this ball is moving in x as well as y direction. That's why we call it the motion in 2 dimensions. After knowing that, another thing which we should know is that under projectile motion we have got 3 cases, and we are lucky that the first question is coming from case 1. So I'll be explaining step by step. So case 1 is a situation where you stand on top of the building, then you throw a ball. Now I want you guys to understand one thing. We are saying that the object is moving in both x and y axis. So when an object is moving in x axis, in x direction, we call this as horizontal. When an object is moving in y direction, we call that as vertical. Meaning that when you throw an object here, for example, the first case which I've given you, in y-axis, the velocity is 0. The vy initial, the velocity is 0. But you are going to have the velocity in x direction, which is going to, so when you read the question, they're talking about horizontal. Just know that velocity, so in this case, I have got the velocity for the x, which is the initial, that is 20 meters per second, but the velocity in y direction initial is 0. When you're throwing something from the top of the building, the velocity in y direction is 0, starting from rest, so you're just throwing it. Okay, so there are few formulas which you need to be familiar with. This is going to be the height, the horizontal distance is what we call the range. So from that point to that point is what we call the range. Now they are going to use, for example, this question part 2, where how far the stone land from the base of the cliff. So from this point up to that point where the stone landed, how far is it? That is the range. Sometimes they'll ask you to say find the horizontal distance. That is the range. Okay, now we are trying to find how long the stone takes to reach the ground. Now the height, we have been told, is 40 meters. So what is happening now is we do know that the formulas which we use under projectile motion are the same formulas which we use under freeform motion. So if you have not watched my video under freeform motion, you can just watch it so that you should have ideas on how I'm going to be solving these questions. So there we go. I have the height, which is going to be the distance. So there's this formula which you need to be familiar with, the v initial. Now we're talking about in y direction. Okay, times t plus half gt squared. So since the initial velocity in y direction in this case is 0, everything here will go. Let me replace s by h. What I'm going to do, I have everything now. This formula can help me to find h. But since I'm trying to find t, this formula can help me to find t as well. I can now do times 2 everywhere to get rid of half, and I'll end up having 2h to be equal to g t squared. So what I'm going to have, I'll divide both sides by g, here by g, so t squared will be equal to 2h divided by g, meaning I get the square root, t will be equal to the square root of 2h divided by g. Let's plug in the values. We find how long was it. 2 times h is 40, g is 9.8. So if I do 40 times, that is 80, 80 divided by 9.8, that should be 8.1. Now the square root of this guy, 2.9 or 2.85. So it took 2.9 seconds for the stone to reach at the level ground. Then how far the stone land from the base? How do we tend to find the range? Finding the range is something that is not hard. So range is given by Vx times t. Now I can show you this. This is the velocity. Velocity is equal to distance over time. So let's make distance as a subject of formula. V, it will be V times t. Now, the distance is the range. Replace d with r. Which velocity are we talking about? You need to be specified, because we have got the velocity in x and the velocity in y, because we are saying that projectile motion is a motion in 2 dimensions. So we need to specify which velocity we're talking about. We're talking about the velocity in x direction, so the Vx times t. The t is the total time, the time it took the stone to reach on the level ground. Okay, now I can clearly see that my Vx is 20, the time is 2.9, so my range will be 2.9 times 20. Okay. Oh, it's 12. My velocity is 12. I don't know where I was getting 20. So it is 12. Even here I'm supposed to replace it with 12 times 2.9. So 12 times 2.9, 34.8. So 34.8 is my range. So that's the basic idea behind case 1. These are the only things you need to know. You need to know how to find the height, the time, and the range. That's all. Now I'll go to part B, the same question but part B. Now the question is saying an athlete competing in the long jump leaves the ground with the velocity of 5.6 meters per second at an angle of 30 degrees to the horizontal. Determine part A, the vertical component of the velocity, part B, the time between leaving the ground and landing. So before I even finish the question, so this is under case 2. Let me now explain. Give me time to explain case 2. Case 2 is a situation where you are standing from the ground and then you throw an object. It goes there, it comes back. So you are going to throw it at an angle with the velocity. In this case, we have been told that the velocity is 5.6. Allow me to put the theta here. Theta is 30 degrees. The moment an object is going to reach at the maximum height, one thing should come in your mind, that at that point the final velocity is 0. That is the initial velocity. That is the h max. So once we reach at the maximum height, the final velocity is 0 at that point. Now allow me to put that point A, point B, and point C for some reason. Now it's basically the same as you have something like this. So I have my velocity to be 5.6. Okay, let me just put it like this. So what is happening is that I have my 30 degrees here and my velocity is here, 5.6, meaning that this is the x component, is my vx, this is my y component. I told you guys to say this is the horizontal, this is the vertical, sorry, the y is the vertical, the x is the horizontal. I want us to go ahead and answer first question 1 and also question 3. So question 1 is saying determine the vertical component of the velocity. What is the vertical component? The vertical component is the y. Okay, so therefore I'm going to say same as vectors, vy will be equal to v sine theta. That's my vertical. I'm solving part 1. So vy will be equal to, the velocity is 5.6 sine 30 degrees. So my vertical component, I'm expecting it to be 5.6 sine 30, 2.8 meters per second. So this one 2.8 meters per second. Then let's go to part that is determine the horizontal component, which is the vx, v cos theta. So vx will be equal to, my v is 5.6 cos 30 degrees. So vx will be equal to 5.6 cos 30 is 4.8. So 4.8 meters per second, 4.8 meters per second is my horizontal. Now I can get rid of this, and I want us to go ahead and also talk about something else. So we are saying this is the vy and this is the vx. Now let's go ahead and also do part 2. So determine the time between leaving the ground and landing. So they want us to find the time from point A all the way to C. But I'm going to teach you two things. How do you find the time from A to B? Now reaching at B, that is the maximum height. So if you do times 2, so I'm going to show you how to find, I'm going to use this V final but in y is equal to V initial but in y plus gt. Now this object is going up. When it reaches at point B, the final velocity is 0. Then Vy is basically V sine theta. Now G, since this object is going up, G will be negative. Now it will be negative GT. Then I'll shift V sine theta to the other side. I'll have this. I'll divide it by negative G. I'll divide it by negative G. So this is basically the time from point A to B, which is V sine theta divided by G. Now, this is the time it's going to take for this stone, or for this ball to reach at the maximum height. So the formula for that is going to be T from A to B is V sine theta divided by G. Now, the time is going to take from A to B, the time is going to take from A to B is basically the same as the time is going to take from B to C. Therefore, I can just do times 2 this formula, then that's going to be the time from A to C. So then I'll say from A to C is 2V sine theta divided by G. Simple, right? Now, how do we find the range? Okay, I'll come back for the range. Let's first go ahead and find the time. So if you want to find the time it took for this ball to reach at the maximum height, you use that formula. You do times 2 is going to be the total time. Or sometimes they're going to ask you to say, what was the time? The time it was in air. That is from A to C. Okay, so they can ask you in different ways. The time it was in air, that is basically the same as the time between leaving the ground and landing. Okay, so there we go. I'll say t from A to C is 2 times my v is 5.6 sine 30 I divide it by 9.8. Okay, so my time now will be, I'll say 5.6 times 2, which is 11.2. So 11.2 sine 30. The answer I find is 5.6 again. So 5.6 divided by 9.8. Okay, so what time are we going to find? Let's see. So it's the same as if I say 5.6 sine 30 degrees 2.8 divided by 9.8. I'm getting 0.28. The answer I find, I need to do times 2 because there is 2 outside here, times 2. So I'm getting 0.57. In simple terms, we can say that this is the same as 0.6 seconds. Now, that is the time. So the time is 0.6. Another question, they're asking us to find the range. The horizontal distance. The horizontal distance is basically the range. So to find the range, because it's from A to C again, so the time we're going to use the same 0.6. So it will be the range is equal to Vx times T. I'm not going to waste time to drive the formula for range because that is a bit complicated anyway. So I'll just go direct. My Vx I already have, which is 4.8. My time is 0.6. I do times. So what is, I'm supposed just to say range and not Rx. So my range will be 4.8 times 0.6, which is 2.88. Or you can say the range is 2.9 meters. As simple as that. That is it for part B. Okay. Now let us go ahead and also solve part C. Part C is now coming from third case, but it's not really complicated because we have not been given an angle. So a boy standing on a cliff edge and throws a stone vertically upward at t is equal to 0. Let's first come up with a free body diagram. So a boy standing here, this boy throws a stone. That stone goes there. Okay, so that stone goes there, but this boy is going to catch this stone again. It goes there and it comes here. Okay, so when it reaches that point, that will be the maximum height. That one we should know. Once it reaches that maximum height, the v final there is 0. So this boy, they're saying that the time the stone leaves his hand when the velocity, meaning that the initial velocity is 20 meters per second. Okay, take acceleration due to gravity g to be 9.81 meters per second. Show that the equation for the displacement of the ball is that. So initially we know that when the ball is leaving, the displacement, the formula which is going to work, the displacement is equal to the v initial times t, okay, plus half gt squared. But since it is going against the gravity, g is going to be negative. So it will be s is equal to the initial velocity is 20 times t plus half. This is going to be negative 9.8 times t squared. So I have got 20 t, negative will be here, then I'll have 9.81 divided by 2, that is 4.905, but since it is just in two decimal places, I'll just put 4.9, then t squared. So this is where that formula is coming from. So we have shown that the displacement is given by that formula. Then another question is, what is the height of the stone 2 seconds after release and 6 seconds after release? So it's just a matter of plugging the values. When t is equal to 2, let's see, s will be equal to 20 times 2 minus 4.9 times 2. So what will be s? So 20 times 2 is 40. So I'll say 40 minus open brackets. So now this 2 has to be squared because t is squared. So it will be 4.9 times 2. I'll square it. 20.4 meters. So we are saying when t was equal to 2, the displacement was 20.4. Now when t was equal to 6, minus 4.9 times 6 squared. Let's see. 6 times 20 is 120. So 120 minus open brackets 4.9 times 6 squared. I close the bracket. I'm getting negative. It is the displacement, so it is making sense to have negative. So when t was equal to 6, then the displacement was negative 56.4 meters. That would mean to say it has reached at that point, it is now coming down. That's why the displacement is negative. Okay. Another question now, which is the last part, is saying, when does the stone return to the gravel? When does the stone return to the level of the boy's hand? Assume the boy's stand does not move vertically after the ball release. So now this boy, after releasing it, then it came back to his hand. So it's basically the same principle as this question, where I was trying to say from point A to B. It's basically the same as from point A to B and B to C. So to find the time in this case, what I'm going to do is I'm going to denote this to be A, that to be B, and that to be C. Meaning the time it's going to take from point A to B is the same as the time from B to C, so I'm going to do times 2. So that formula, I can just use this. The V initial in Y, the V final is the one we start. So the V final now in Y is equal to the V initial in Y plus GT. So the final velocity at B is 0, so I'll put 0. This will be V sine theta. Since it's going against the gravity, you have negative GT. Shift that to the other side, I have that. But there's a problem here. The angle is 90 because it's just straight. So it's the same thing even if I don't include the angle. We have not been given the angle. So just leave it. Just push that one to the other side. You have this. Now G is negative. Divided both sides by G. Negative G. T will be equal to, the velocity is 20 divided by 9.8. So T will be equal to 20 divided by 9.8, which is 2.04. So we have 2.04 seconds. Now, one thing I want you guys to understand is that this is the time from point A to B, but to find this is the time it was in air, the time it took for the ball to go up and come back. So you do times 2. So you say 2. So the time you are looking for is 2.04 times 2, which is 4.08 seconds, or you can say 4.1 seconds. So but just a minute, I had to replace G with 9.8, but we have been told that it should be 9.1. Let's see now. Maybe I forgot 1 there. So 20 divided by 1, 9.81. So it's 2 point, but it's basically the same thing, It's same, guys, because it's 2.038. If I round it off, 2.04. So it's the same thing. Yeah, it's same. So that is it for part C. Now let's go to the last part for this question, which is part D. A train is traveling at 50 meters per second when the driver applies the brakes and gives the train a constant acceleration of magnitude 0.5 meters per second for 100 seconds. Describe what happened to the train. So what was happening to the train is that there are just few things which was happening. The first thing, the train was moving at 50 meters per second, quite okay. So the moment the driver pressed the brake, it didn't come to stop. Okay, so it started now. It was about to go to stop, but it was not stopping, because if you can check the time here which you have, after 100 seconds, then after 100 seconds it came, after 100 seconds, that's when now it came to 0.5. So we can say 0.5 meters per second. It was about to come to rest. So what was happening was, every after, okay, every after second, or maybe per second, the train was now moving with the speed of 0.5 meters per second. So every after second, for 100 seconds, every after second, the train was now moving with 0.5 meters per second. I think you're getting the logic there. So in short, what was happening is, the brakes were not enough for them to for the train to stop moving. So that's the reason why it just keep on moving with a acceleration of 0.5. Okay, so you can see the duration was just too much, 100 seconds, which is about a minute 40 seconds. So it was just too much. So it was moving at 0.5 meters per second each second for about 100 seconds for it to come to rest, but it didn't come to rest. Okay, so that's what was happening to the train. Then part 2, they're saying calculate the distance traveled by the train in 100 seconds. So in 100 seconds, we have the time, the acceleration, and everything. So I think the best formula I can use is this one. Now in this case, I'm not going to use G because I'm using acceleration, the linear acceleration. The initial velocity is 50 times the time is 100 plus half. Now, one thing I want you to understand is, the acceleration is going to be negative because it was decelerating. Time 100 squared. So this is going to be 5,000. Yes, 5,000 minus, that is going to be 100 squared times 0.5, again times 0.5, because 1 over 2 is 0.5. So I'm getting 2,500. So if I do 5,000 minus 2,500, again I'm getting 2,500. 2,500 meters, of which, if I want, I can put this in kilometers then it's going to be, I'll divide it by 1000. But if you want, just leave it like that, so it will be 2.5 kilometers, but I would advise you to leave it there. Now I think for question 1, that is enough for you to know. Yeah, that is enough for you to know. Yeah. So that is it for question 1. In this video we are going to continue looking at projectile motion. So we have question 2 now, which is saying a stone is thrown with the velocity of 8 meters per second into the air at an angle of 40 degrees to the horizontal. Calculate the vertical component of the velocity. Now, before we even read the questions, I think it's important for us to know which case are we dealing with. So this is the second case where I said, in question 1, I said, you are just on the ground, on the level ground, and then you throw an object, okay? Or you kick the ball, so it goes under projectile. So the moment it lands there, that is a projectile. Now here is a free body diagram here, guys. I'm going to give you a free body diagram. So here is a ball, it goes there, it lands there. So that point here is my maximum height. I'll call that as h max. The horizontal distance is what we call the range. So remember, it's going to be thrown at an angle, like we have said. The angle is 40 degrees. The initial velocity is 8 meters per second. Once it reaches at the maximum height here, the final velocity is 0. Now we can start solving the questions. So when we're talking about the vertical component and the vertical component and also the horizontal component, it's a case where we have in this case what we have is we have something like this. So we have the x component and the y component. Here is my 40 and here is my velocity to be what? To be 8 meters per second. So this will be my Vx and this will be my Vy. And you know that when we're talking about the Vy, we're talking about the vertical. Vx is horizontal. So we are talking about, we want to find the vertical component. The same things we're talking about under vectors. Vy will be V sine theta. So Vy will be, the V is 8 sine 40. So what is 8 sine 40? That is 5.14 meters per second. That is my vertical component of the velocity. Okay, then part 2 is saying state the value of the vertical component of the velocity when the stone reaches its highest point. Ignore the air resistance. The moment you are going to reach at the highest point is the maximum height. You reach at the maximum height, the velocity is 0. So like I said, when you reach at the maximum height, the velocity is 0. So the answer there is just 0. The velocity is 0 at that point. Okay, then part 2 is saying use your answer to 1 and 2 to calculate the time the stone takes to reach its maximum height, its highest point. Now to find the time at the to reach at the maximum height, one thing we should know, guys, is we are going to use this formula. V final is equal to the V initial plus GT, because I don't have the height. Okay, I don't know the height, so I can't use the formula which is going to give me the height because I'm trying to find the time. So once it reaches at the maximum height, it's 0. So V, we are dealing with Y, so it's V sine theta. Now I'm going to put minus because it is going against the gravity. G is now negative. Shift V sine theta to the other side, you have negative V sine theta is equal to negative GT divided by negative G, negative G. Time That is more like we are finding time from A to B, like I said from question 1. Then C, if I want to find the time from A to C, the time I'm going to find now times 2 is the time from A to C. But we're just find right now we're just trying to find the time from A to B. So it will be V is 8 sine theta, of which is 5.15. We have already found there. Okay, sine 40. I divide that by 9.8. So T will be equal to negative and negative has gone. So we are talking about 8 sine 40. The answer is already 5.14 divided by 9.8. So I'm getting my time to be 0.52 seconds. Now this time, it is the time it took this for this trajectory, for this stone to reach at the maximum height. If I go to part 4, which is saying calculate the horizontal component of the velocity, it's just the Vx. So Vx is V cos theta. Then Vx is 8 cos 40. So what is it's going to be 8 cos 40, which is 6.13 meters per second. That's my Vx. Now again, the next question is saying use your answer to initially they wanted us to find, they're saying use your answer from 5 to calculate the horizontal distance traveled by the stone. So we're using the answer for part 1, part C, A, B, C. Yes, we're using the answer for part 3 and 4, and not this. They were supposed to ask like this. They were supposed to say use your answer from part 3 and 4 to find the horizontal distance traveled by the stone as it climbs to its highest point. So it's like we are trying to find the maximum height, the height when it reaches at that point. So I'm finding not the range, but the maximum point is that point. So that point, now they want us to find the distance from that point to that point. That's all. That distance. That's what they want us to find. So it's basically the same thing where I'm going to say the range is equal to Vx times t. Now time is the same time, because this time is the time that's why the question is specified actually. We're using the answer from part 3 and 4. So the time we found there is 0.5, and the V we have found, the Vx is 6.13. So it's just basically to plug in the values. 6.13 times 0.52. So the range will be equal to 3.19 meters. That will be the range. Now, in a case where the question was find the horizontal distance traveled by the stone as it reaches or as it lands on the ground, then I was supposed to use the total time, which is from A to C. So to find that time is just to do times 2 of this time. That is the total time. So it's the one I was supposed to use if the question was find the horizontal distance traveled by the stone as it lands or as it reaches the ground. I hope you are getting the concept there. So I've used 0.2 because the question is specified to say we are using the answer for part 3 and 5. Okay, that's the basic idea behind that. Now the last one here for question 2 is saying a stone is thrown horizontally from the top of the vertical cliff and lands 4 seconds later at a distance of 12 meters from the base of the cliff. Ignore the air resistance. Let's first come up with a free body diagram. This is case 1, where you have got from here you throw an object, it goes there. I expect to have the range which you have been given. In this case they're saying that the time is 4.0 seconds, then at a distance of 12 meters from the base of the cliff. So it lands there. Okay, so a stone is thrown vertically from the top of the vertical cliff and lands 4 seconds letter at a distance of that. So that is my range. That's my range. So now we are trying to find, I don't know, the h, that one. So the question is, calculate the horizontal speed. The horizontal speed is the speed in x-axis. Now that I know the formula for range, remember I told you that range is given by vx times t. So now I have the t and r, which is the range. Range is 12. Make vx as a subject of formula, that is the horizontal speed. So vx will be equal to r divided by t. So it will be 12 divided by 4. My vx will be 3 meters per second. The velocity in x direction doesn't change. That is what we need to know. The velocity in x direction doesn't change. It remains the same. Then part 2, calculate the height of the craft. I told you to say for case 1, when you throw an object from here, the object is going to have the horizontal speed, which in this case it is 3 meters per second. But the vertical speed is 0. The initial vertical speed is 0. So in this case, we are assuming that we are not assuming, but that's how it is. The velocity in y direction is 0, and I'm trying to find the I'm trying to find what that should be 4 seconds. I'm trying to find my h. So you realize that that formula for displacement is equal to the v initial plus t plus half gt squared. But the v we are talking about here is the vy. So I need to be specified. I'll say vy initial times t plus half gt squared. It is coming down, so g is positive. Now the vy initial is 0, like we said, because you are releasing an object from the rest. So the vy initial is 0. So replace s with h. So s is basically the h we are trying to find here. Okay, so it's now h. I will replace this by 0. So 0 times t is just 0 plus half gt squared. So it's basically h is equal to half gt squared. Now I have everything. It's just a matter of me plugging in the values. My h will be equal to half 9.8 as my g. My t is 4, but we square it. So what will be h? So now I have 4 squared times 9.8 times 0.5. 1 over 2 is 0.5. And I'm getting my answer to be, let's say, 0.5 times 9.8 times 4. Now I square it. Don't forget to square 4. So the answer I'm getting is 78.4 meters. That is the height of the cliff. That is it for question 2. So now we can clearly see here, guys, that we have remained with 2 questions. Now for you to access those videos, it will be easy for you to access them from our website. Just register with us at affordable price. So you can get in touch with me using this number, +26 0767 729927. Get in touch with me right now and you'll be able to access the full tutorial sheet solutions and also more practice questions under projectile motion, because I have advanced practice questions which can help you to understand more on this topic. Okay, so I have all the videos from dimension analysis up to mechanical properties of matter, everything, both the practice questions and full topic videos. Okay,